Hi Year 10, this is a talking mark scheme, if you like, to explain the answers to the resultant force using parallelograms worksheet from last week. Okay, first three diagrams. I just wanted you really to sketch these to get the idea of drawing a parallelogram and the direction and rough size of the resultant force. Being able to do these and kind of cross-check makes it easier to spot mistakes when you're doing the scale diagrams. So you can see the three here. All I've done is completed the parallelogram and drawn the resultant force as a diagonal each time. Okay, down to business then in terms of drawing a scaled diagram. Let's have a look at this first question in detail. So we've got a force of 6 newtons and a force of 4 newtons acting on an object at an angle of 45 degrees to each other. Draw a scale diagram and calculate the size and direction of the resultant force. So the first thing I'm going to do is I'm going to take the first force, I'm going to take the largest one, 6 newtons, and I'm going to use a scale of 1 newton equals 1 centimetre. Now that's a nice easy scale. Try and find yourself an easy scale when you do these. Make sure you give yourself enough space on plain paper, and I'm just going to draw a 6 centimetre line there, trying to be as accurate as possible. I'm going to label that one with 6 newtons. And before I can draw the second force, I need to measure the 45-degree angle. So protractor at the end there, let's get that right on the line. 45 degrees, I just put myself a dot there. And I know that's my 45 degrees, but I only need a 4 Newton force, so I'm just going to line the ruler up with the dot at 45 degrees, and I'm going to draw myself a 4 centimetre line to represent 4 newtons. And I know I now got that angle of 45 degrees. I'm going to add arrows to show the direction of the two forces, and what you can see now is a scaled vector diagram. Okay. Next part is to find the size and direction of the resultant force. And I think this is the bit that people find tricky. There are different ways to do this. You can do it using graph paper rather than a compass. So what I'm going to do is, I know from looking at the diagrams in the first question, I know roughly where my resultant force is going to be. I know it's going to be up here somewhere. And the way I'm going to do that, what I'm going to do is I'm going to measure, I'm going to set the compass at 4 centimetres. Just going to try and tighten my compass a little. Sorry about tape on the compass, it was broken. And I'm going to then draw an arc, and it's just moved a bit. Hopefully your compass is a little better than mine. So 4 centimetres, and I'm going to draw an arc from the opposite end of the opposite force measurement. And then I'm going to do the same again. This time I'm going to get the 6 newtons. So I'm going to have a 6 centimetre on my compass, and I'm going to draw a second arc. Very hard to do it and get it on the video. From the end of that force. That's not very good. Second arc there, hopefully you can see that. And where the two intersect, that is where your resultant force is going to end up. So I can actually complete the parallelogram, and I should find that that's exactly 6 centimetres or 6 newtons, and that should be exactly 4. That's a way of cross-checking it's correct. And then I can show my resultant force here at the diagonal. I'm going to add an arrow to show the direction. I can then use the ruler to measure this. So I'm getting about 9.2. And because I've got 1 centimetre is 1 newton, so 9.2 centimetres is 9.2 newtons. And the last thing I need to do is measure the angle. So then I've got around 19 degrees, okay, from the 6 Newton force. So that is the size and direction of the resultant force. So you can say it's 9.2 newtons and the direction is 19 degrees from the 6 Newton force.